So we've talked a few times about valve authority and the importance of valve authority on a mixing valve. Just to recap a little bit, the basic theory of authority is that the pressure loss through this mixing valve here should be around equal to the resistance through the circuit. And so this is that the valve in effect can actually control the rate of flow through it. It's not a very good explanation, but I'll try and explain it a few different ways to see if we can make it clear. But to give you an idea, so where I've installed valves with incorrect authority, what you will see is that the valve will open a tiny bit like this, and that tiny opening is wide enough in the valve to allow such a high rate of flow through that basically it will cause this system to overheat. So basically this will keep switching backwards, so you'll see it move open, overheat, close again, overheat, and this will drive the customer nutty because these boxes have a relay inside and it'll go click, whir, and backwards and forwards. I've got an example of this on one I've done on a Vaillant boiler. So what we want in effect is we want this full range to be controlling the flow. So if we want it to be fully open, the valve will be in that fully open position, and we need to make sure this is right. So now on this circuit we've got around about the same load on our underfloor heating circuit as we have on our radiator circuit, but the flow on our underfloor heating circuit is at delta T5, so it is 4 times greater than the flow on this mixing valve. So this mixing valve, these mixing valves have a very different KVS value on them, or KVS value on them to gain the same rate of authority. So this one, in effect, the actual opening in it when it starts to open is much greater than the opening in this one. And that's required because obviously we've got to let a lot more water through in this circuit in the fully open position, which requires a wider orifice. Whereas in this one, when the fully open position, we've actually got a very small orifice. In fact, some of these, the valve opening is like a hacksaw blade slot. So it's a small ball which has got like a slot the size of a hacksaw blade in it through the smallest ones. Where these have got quite well, it varies in size, but the higher the KVS, the higher the KVS value, the bigger the hole through the ball, and actually the bigger the valve as well, as the valves go up to an inch and a quarter as the KVS values increase. So I'm sorry if that's not very clear. It's a fairly difficult concept to explain. So anyway, make sure you get your KVS values correct. All you need is the heat loss and the delta T of the circuit and the ESB app. You can load that data in and it will tell you what KVS value you want for your valves. The same if you're buying mixing groups, just make sure that you've got the right KVS value for your mixing group as well. I know some of those come in, the smallest KVS is actually quite big. You've seen some of my videos where I've installed those mixing groups, but they're in very big houses, not in a small place like this where they just wouldn't be suitable. So anyway, as usual, I hope that helps.